All right, good afternoon. We have a question about how to solve and graph a hyperbole. Okay, or hyperbola rather. Hyperbole means something else. So I'm just going to kind of take us through each of the steps here that they have on the problem. So what we're going here, you can see it's the same problem. So I'm going to do a little bit of pushing on this before we get started. So the first thing I would always want to do with a hyperbola is to turn this thing into something with standard form in it, okay? So the first thing I would want to do is take my 100 y plus 6 squared minus 25, x minus 4 squared equals negative 2500. I want to make this right-hand side a 1. So my first step here is to divide everybody by negative 2500. Okay, and what's going to happen here is I'm going to get a negative y plus 6 over, let's see, that's going to be a negative 25. I'm going to get, oops, I already counted for the negative. We're going to have a plus x minus 4 squared. The 25s cancel. We end up with 100. The negative times negative cancels. So we end up with a positive there, and we get a 1. That's kind of what we're looking for there. So let me turn this thing around and put the positive form first. I just like the positive one at the front. It doesn't have to be this way, but that's just how I tend to like to do this thing. Okay, over 25, that's a squared, and that's equal to a 1. So we have x minus 4, quantity squared, over 100, minus y plus 6, quantity squared, over 25. And from here, we could pull off the center, right? It's the format, so we have this in a good form now. So the format is always x minus h over a value. We'll put a plus or a minus here. Minus plus, they're going to be opposite signs. Y plus 6 squared over, or y plus k, we'll say a k, we'll do not specifically, is equal to 1. And put a minus there. And the center is always hk. So it's important to remember the negative sign there is actually there to fool you. Since it's x minus 4, my center is at 4, and x plus 6, that really means y minus negative 6. Okay, so we have a negative 6. So my center here, okay, is 4, negative 6. So let's go ahead, we'll punch that in and make sure we got the right answer there. So it says, where's the center? What did we say here? We said it was 4, negative 6. So we'll just type in 4, and we have a negative 6. And we'll make sure that's correct, and then we'll just keep going. Okay, where are the vertices? Okay, now you got to remember that in a standard position hyperbola, this is real easy to sort out, but in a center, right, when it's a little bit off center from the origin, we've got a little bit different here. Okay, so the vertices, well, we got to figure out, okay, we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, so it's going to be the center. Okay, so I'm going to go from my x value, and I'm going to add, right, plus or minus 10. We're going to set our y equal to negative 6. We get a 0, and we've got to go ahead and solve for this. Okay, so we have x minus 4 squared over 100 equals 1. We've got x minus 4 squared equals 100. X minus 4 equals plus or minus 10. And x is equal to 4 plus 10 or 4 minus 10. So our vertices here are at 14 or at negative 6. All right. So, but we have to remember, like, we're still down a bit vertically here. Okay. So my values for my vertices are either 14, right? That's the value we got over here, 14. What would my y value be? My y value we set to negative 6. And then the other one is going to be at negative 6 negative 6, okay? So you got to remember that you're offset, you're off center. This is the easy way. It tracks it for you, so you don't have to continuously go back and recount it. But you would know that it's also 10 away from the center, okay? Um, so we're looking at the positive one, okay? Whichever one is the positive one is the one you're going to figure out where the vertices are. And it's just whatever distance this is, plus or minus away from the center. So you could put the center there and then put 10 relative to the center, or you could solve it this way and it kind of takes care of the arithmetic for you. But that's what we're looking at for that one. Okay, so that's how you figure out the vertices. Okay, so we have negative, or no, we don't have a negative. We have a 14, negative 6, negative 6. Okay, and then we have negative 6 and negative 6, I believe, right? Double checking that, double checking. Okay, let's go ahead and make sure we're correct there. All right, and now we're going to figure out the foci. Okay, and similar to, I'll go ahead and put this down. Similar to the vertices, the foci are going to be relative to where the center is. Okay, so to figure out the vertices, or to figure out the foci, all right, we have a c squared is equal to a squared plus b squared. In an ellipse, there's a minus sign here because it's interior to the thing. This is exterior to it. So my c squared is equal to my a and my b, and it doesn't really matter which one of these you call a and which one of them you call b. Just remember that your major axis is the big one and your minor axis is the little one. Okay, they use a different vocabulary word for hyperboles or hyperbolas, but so this is going to be 10 squared plus 5 squared. You don't even need to do the arithmetic. You can just read it right off of that and say that we have c squared is equal to 100 plus 25. So c squared is equal to 125 here, all right? And c is equal to plus or minus the square root of 125. 125 is 25 times 5, so we're going to say c is equal to plus or minus 5 root 5, all right? Just to make sure that the book stays happy, and honestly, you should reduce that anyway, regardless of you're doing it on paper, you're doing it in a book, whether or not they tell you to. It's just good form to pull out the big numbers out of your square root. Okay, so let's go ahead and put that in. Oh, before we do, we have to remember, right? Where is our center? Our center is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So the vertices, the foci rather, are going to be this value here plus 5 root 5, and it's going to be this value here minus 5 root 5. So my center being 4, it's going to be 4 plus 5 root 5 and 4 minus 5 root 5. And then this is something that you get so excited that you found the x coordinate. Where am I on my y coordinate? I'm still at negative 6. I'm still at negative 6. So be careful about that. There's a lot of things going on in this particular problem. It's really easy to kind of, work on this stuff that's technically the hard part and then forget that you are working relative to this different center other than the origin. Okay, so these are a little tricky because there's a lot to keep track of. Okay, so let's go ahead and put that in, and we're going to have 4 plus 5 square root 5, and then we're going to have a negative 6 here, and then we've got 4 minus 5 root 5, and then we've got a negative 6 here. Okay, the book said we're going to use exact values, and we probably should use exact values. Okay, so we'll check our answer, and then we're going to be okay with that. Now, let's work on our asymptotes. Okay, again, I'm going to put this down for a bit so we can actually do some work and figure out what they are, and then we'll come in and plug the value in. Okay, so the important thing about being able to draw a hyperbola is to be able to draw the box. All right, the box is going to be the A and the B. All right, so where are we starting from? We're starting from, and what's my bigger one? My bigger one is in Y. Nope, the bigger one is an X. Okay, so let's go ahead and move this a little bit. So we have our eraser. All right, so the big axis is going to be an X. All right, and we're still going to be below the, so here's my X, here's my Y. A lot of times being able to solve a problem well is being able to draw a coordinate system that is useful for you. It takes some practice. When you get into physics, you get a lot of practice, but it's one of those things that you always kind of wonder. It's like, oh, I should have thought of that. I'm like, yeah, I know. But if you're not thinking about, if you haven't done a lot of problems where you have a coordinate system that's a little bit off from the origin, it's hard to know. I want to kind of draw here's my 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, here's my center. Okay, now the box is going to be, right, we're going to have, where's my thing here? It's going to be 10 and 25. So my X value is going plus or minus 10 from the center. My Y value is going plus or minus 5 from the center. Okay, so how I got the 10, I took the square root of 100. How I got the 5, I took the square root of 25. Okay, and the slope, okay, is going to be the same thing that you've always dealt with. The slope is always going to be the rise over the run. Okay, so the way we would do this, right? 1, 2, 3, 4, 5, and then we got to go out another 10 more. So 1, 2, 3, 4, 5. 1, 2, 5. Okay, so we're at 4. 4 plus 10, we're going to be at 14 here. Okay, so that's one point. And then I've got to go up 5 because 1, 2, 3, 4, 5, and then we're going to go down. So we're here at negative 6, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we're going to go from 6 down to 11. Okay, and that's going to happen on the same thing on the other way around. Okay, we're going to have negative 1, 2, 3, 4, 5. Okay, so we're going to go. Okay, I'm terribly sorry about the fact that my drawings all suck, but that's I would never penalize somebody for making drawings about this good. Okay, if it's as good as a fourth grader can do, we're going to be okay here. So we have got 4. 4 minus 10 is going to be negative 6. And again, we're going to go up 5 and down 5. Okay, and this is your box. Okay, the asymptotes are going to go through the corners of this box. All right, let's go ahead and make that something a little bit lighter, but maybe in a different color or something. So here's my asymptotes. They're going to go through okay, pretend that went through the corner. Okay, and the same thing here. And the other thing you have to do is pretend that these are straight. Okay, one of the things you're going to notice is it goes through the center. Okay, so that's an important thing. So let's go back to a color we can see. All right, so my slope here, right, is going to be the rise over the run, and the rise is going to be 5 and the run is going to be 10. So the slope is going to be plus or minus 1/2, right? We've got a plus 1/2, we've got a minus 1/2. But in order to make a line, we need a slope and we need a point. Okay, and considering both of these lines went through my center, right, my point is going to be where the center is, which was 4, negative 6. Okay, so what we're going to do is we're going to do point slope form. We're going to say this is y minus y0 is equal to m x minus x0, and that's how we're going to figure out the equation of this line. So we've got y minus a negative 6 is equal to 1/2. Okay, and then we have x minus 4, and then we have to go through and plug that in. So we have y plus 6 equals half x minus 2. Go ahead and add the 6 to both sides. So we have y is equal to half x plus, right, we're subtracting, so minus 8. Okay. All right. I know that the numbers on this one are a little bit easier than some of the numbers they give you because they give you thirds and these are halves, and I promise you I'm not cheating because I'll show you when we get to the drawing of the graph that this number here didn't really matter. I mean, it matters, but it didn't really matter as far as how we're going to place these graphs, how we're going to place this on the graph. Okay, so I know I just selected a random problem, but I know numerically this one was conveniently easier than the other one. That was not my intention. I was trying to find one that was about as difficult, and some of the ones that I found were a lot easier, but I didn't want to cheat that way. Okay, so my other line, right? We also have y minus y naught equals m x minus x naught, and we have y plus 6 is equal to negative 1/2, and then we have x minus 4. So the point it's going through is the same, I just changed the slope, okay? So we have y plus 6 is equal to negative 1/2 x, and that's going to be a plus 2. We're going to subtract 6 from both sides, and we'll say y is equal to negative 1/2 x, and that'll be minus 4. Okay, so the two equations I have are half x minus 8 and negative half x minus 4. Okay? Yeah, okay. Just double checking to make sure my signs are good because that's the place where I'm going to mess this up. Okay, so we're going to go ahead and say this is 1/2 x, okay, minus 8, and then y equals negative 1. Oops, that's not anything. 1/2 x minus 4. Okay, so let's go ahead and we'll double check that one. All right, so we're all good. All right, and then we get the luxury, we get the fun of graphing it. Now, I'm getting up there, and I haven't had my glasses changed in a couple of years yet, and I clearly need that. So what I'm going to do here is I'm going to blow this up. I'm going to hit the control and the plus button at the same time so I can actually see what the heck is going on with this graph, so I don't have to strain my eyes trying to count out little dots and figuring all of that out. So here we go. We're going to go ahead and use this tool to help us write down the point. We're not going to use the pencil at all. We're just going to use this guy here. Okay, so we're going to go ahead and hit that. And it says, where's the center? Well, my center was 1, 2, 3, 4, and then down to 6 here. So I'm going to double check to make sure that my dots are at 4, negative 6. These sure are. Okay. Let's see here. I'm going to double check to make sure I've actually got that at the center. Let's see. 4, negative 6, beautiful. Now we're going to place the vertex, and my vertex, and you only need to place one of them because it knows that you know that they're equally distant, okay? So I'm going to double check my vertex. It's a 14, negative 6, right? That was one of my vertices. So we're going to go here. Here's my 4, okay? And we're going to go out to where it says 14. We stayed on the negative 6 line here, okay? So you can see the bold vertical line is going through x equals 14, and we stayed at the same depth. We stayed at the same negative 6. So we're going to put that in there. And now we've got to place an asymptote. Let me make this a little bit bigger for us so we can see what's going on here. All right. Remember that it was the rise over the run, okay? So I'm already out 10, right? I'm already out 10 from where I was. What was the rise? The rise was 5, so we're going to go up. 1, 2, 3, 4, 5, and we should be at negative 1 there, and it looks like that gray line is going through negative 1. So even if you have the craziest things in the world as far as your numbers go, the values that they give you to graph are always integer values. Okay, they're not going to take that away from you to make that integer. So that's how they want you to graph this thing. Okay, they don't want you to get the pencil out and plot the points. They want you to use the tool. Okay, and hooray, we got it all right. And okay, I've got check marks all around, so that makes me feel satisfied and happy. You get your little shot of hormones saying that you did a good job there, so you want to do more. Okay, but that's how they want you to graph this. They don't want you to mess around with this pencil tool. I guess you could, but I really would not want to mess with that. Okay, so I hope that helped graph this thing, and let me know if we need more help. Okay, I'm happy to put one of these out for a guided problem solving thing. Okay, so I'm going to go ahead and stop this, and I'll let you go with that. Thank you very much for asking the question.